Short video, about 10 minutes worth, will be an introduction to Chapter 0, Section 1 in our pre-calculus book for this year. Chapter 0 is called Preparing for Pre-Calculus. So this should be mostly review, and I want to get you back into the swing of math and introduce you to the way I say things, and I say them the way I say them to prepare you for pre-calculus, to prepare you for calculus. So we're not going to do all of the sections in Chapter 0, we're just going to be doing the first few. Today I'm going to talk about Section 1. Section 1 is called sets, so it's all about sets. And we're going to discuss some aspects of set notation to get you ready for class tomorrow. So let's go on to the next one. Section 01, the objective, unstated, but I'm going to state it anyway, is to get you back in the swing of doing math. We're going to talk math, we're going to write math, and you need to be able to understand how to do that. So the real objectives for this first section are to be able to use set notation to denote an element, a subset, components, supersets, that sort of stuff, and to find the intersections and unions of various sets. I don't expect you to remember what all of those words are right now, but by the end of this video, you should have a working knowledge of all of those terms. So really, what is set notation? If you look right here, I will do a little highlight. This section right there, the way you would say that is the set n includes 1, 2, 3, and 4. So that is set notation for the set n, and the elements in set n are 1, 2, 3, 4. Elements are all of the individual pieces inside of a set. The notation down below that I'm doing in blue here, the next page I'm actually going to give you the definitions of those straight out of the book. So if you want to pause for a second, see how many of them you can remember from previous classes. If not, let's go on to the next page. Okay, so this is straight out of page P4 in your book, and it explains what all of these various terms mean. The funny looking E means is an element of. So if I were to write 3 is an element of set A, that means set A has an element of 3. The key point here is an element is just one term. The second point, you put a line through something and it's not an element of. Then you have is a subset of. You can also have not a subset, so the book will use on occasion the subset form and put a not through. So you might have something like set A is not a subset of set B, something like that. Next term, a complement of a set. We will do an example of this, but if you have a universal set and you have a subset A, the complement would be everything in the universal set that's not in A. And the intersection of sets A and B would be everything that is in common between sets A and B, and the union of sets A and B would be everything in set A and everything in set B. So for an intersection, you might have something like everyone that is a junior at OCA intersection with all the guys at OCA, and that set would just be all of the guys that are juniors at OCA. But if you did the union, all of the juniors at OCA and all of the guys at OCA, all of the juniors would include the guys and the girls, and all of the guys at OCA would include the guys in the 9th, 10th, and 12th grade as well. So that's kind of how intersections and unions work if you're talking about sets of people. And what we will do in the examples today is mostly sets of numbers, but you can do sets of other sorts of elements as well. Okay, give this one a shot, and I'm interested to see if anybody can read this notation. This is called set builder notation. And you may have written something in set builder notation last year when you were talking about domain and range of a function. So this would be, if maybe it was the domain, let's say we're talking about the domain of some functions d is equal to x such that x is greater than or equal to 3 and x is an element of all real numbers. Interesting way to say that, and that is the math language that I want you to get started on today as we get ready to go into this year. So let's go and let's look at some sets. So we have a universal set that is all of the integers from 0 up to 9. And then you have various other sets, A, B, C, D, and E, and all of them are subsets of the universal set or portions of the universal set. So the first question, can you read this notation? What does that say? What is the question there? And it is, B is a subset of C. So the question you have to ask yourself, is B a subset of C? So in order to check that, you have to find the terms in B. 5, is 5 in C? Yes. 7, is 7 in C? Yes. So B is a subset of C. I'll put a check mark by that and write yes. Every element of B is in set C. Therefore, B is a subset of C. The definition of a subset is every element of B would be included in set C. So that's our first one. Second one, is E a subset of D? So let's look at E and D. If you go to your first number in E, first element is 3. 3 is in set D, but when you go over to 6, 6 is not in set D. So in order to make this true, it would have to be E is not a subset of D. And that would be proper notation. You could put a check by that and put yes now after you put the cross line through to say E is not an element of D. So going on to our third example, is C an element of A? And if you notice, we got more terms going on here, and these sets can be huge. They can be all integers from 0 to 100 or something like that. So it's much easier to write things in set notation than to write out the set every time. So let's take a look here. We'll go back up to the pen. Is C an element? So we have 1, 1, 5, 5, 7, 7, 8, 8. So that's true. C is a subset of A because all of the elements of C are elements in A. So now we want to find the complement of A. And the way that I do this, you go over to see you have A, you have 1, so I'd cross out the 1, you have a 4, cross out the 4, you have a 5, cross out the 5, 7, cross that out, 8 and 9, I'll just cross those out. So the complement of A is going to be everything I haven't crossed out. So I'm going to circle those in a different color so that I can write all of those down. It's an easy way to keep track, so it's going to be 0, 2, 3, and 6. So the complement of A is everything that's in the universal set that is not in A. And that's a pretty straightforward process that I just showed you to go through and check those off. And one way to look at that, if you had set A is all of the students at OCA taking advanced pre-calculus, all of the juniors taking advanced pre-calculus. If the universal set was all of the juniors and set A was everyone taking advanced pre-calculus, the complement would be all of the juniors that aren't sitting in the classroom tomorrow when we get together again. So that's how the complement would be applied. So we've just got a couple more going on here. So we're going to do B intersect C. So let's take a look at B, and let's take a look at C. And we have to see what terms are in common. So we have 5 and 5, 7 and 7. Those are the terms that are in common. So if you were to draw a Venn diagram, if you had, let's call this set B and this set C, set B would have 5 and 7, C would have 1 and 8 out here. They're not part of set B, but they are set C. And this, it's a little bit misleading because everything in B is in C. So if you really wanted to draw it correctly, you would say this is C. This would be B. Inside of B would be 5 and 7, 1 and 8. So B intersects C would be 5, 7, or if you simply wanted to write that as B, because B up here is 5, 7. So the notation would be the same. Last example that we're going to go through, A union D. So let's go up here. So everything that's in A and everything that's in D. And if you notice, 1, 2, 5, 7, 8, 9. I'm sorry, 1, 4, 5, 7, 8, 9, and this has 2, 3. So really what we're talking about for the union is it's going to be 1, 2, 3, 4, 5, 7, 8, and 9. Okay, so that would be everything that's in A would come down here, and then everything that's in D, what we really added, so we added 2 and 3. Everything else was in A, and then we added that for D. So that's the way you would do a union. And if you had a Venn diagram and you needed to do a union Venn diagram, that's called the universal set. That's A, and that's B, and I'll label them up here. A and B. If you needed to shade in the union, it would be everything inside of both circles. I'm not going to take the time to shade in everything perfectly, but that's what a union would look like. And an intersection, I'll do that just in green. The intersection would just be the area in common in here. Okay, so that's just a quick overview of set notation and how to use set notation. I just want to review quickly the different types of numbers. So you have, I call them counting numbers. Most math books call them natural numbers. And I call them counting numbers because when you count on your fingers, you start with 1. 1, 2, 3, 4, 5. So they're all of the positive integers. Whole numbers are counting numbers plus 0. And I refer to whole numbers as non-negative integers. 0 is not negative or positive. So when you look at integers, since 0 is not negative or positive, if I say non-negative integers, it would be positive integers and 0. And then integers, you're quite familiar with those. Those are whole numbers, both positive and negative added together. Rational numbers, which are Q, you've heard them in the past. Mrs. Jenkins last year said that you can write them as either a terminating decimal or a repeating decimal. I prefer to use a different definition. It means the same thing, but I prefer to say that you can write it as a fraction. Because this year we will be doing a lot of fractions, a lot of exact values. An irrational number is a number that can't be written as a fraction, such as pi, or I'll throw in here the square root of 2 is another one that cannot be written as a fraction because the decimal does not repeat or terminate. And then real numbers are all rational numbers and irrational numbers lumped together. And a complex number compares both puts together both a real and an imaginary component, and I know you dealt with those last year. So one last slide just to show you a Venn diagram. You have the integers in yellow, and inside of the integers you have all the non-negative integers, which are whole numbers, 0, 1, 2, 3, 4, dot, dot, dot. Inside of whole numbers you have natural numbers, which start with 1. They're all the positive integers. So this is 0. This is 1, dot, 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 dot. This includes the negatives. Rational numbers can be written as a fraction. Irrational numbers cannot. Both of these sets together make up the real numbers, which is R. And then outside of the real numbers in this universal set would be complex numbers, which would include real and imaginary numbers.